Running JBoss AS7 in standalone mode. First, let's download the AS7 zip. You can download it on this site. Once you've downloaded it, extract the files, and this is what the file structure looks like. Start it with the bin standalone script file. This will start up the default profile, which is a web profile. As you can see, when it's started, you'll get this line in your server log file. So let's stop the JBoss instance now and take a look at the profiles in more detail. Under the standalone configuration directory, there's various standalone dash files. They are full HA, and the default web profile. So this is the one we just used to start up. But if we have a look at the standalone full profile, it has some extra subsystems which aren't available in the web profile, such as messaging. And messaging on JBoss is implemented with Hornet queue. So if we start up again, but this time use the server config argument to specify which config file we want to use and specify standalone full, then we'll start up in the standalone full profile. And once this one's started, we'll see that the Hornet queue subsystem was started. So that's how to run in standalone mode. Running in domain mode. I'm going to show you how to run in domain mode, which lets you share configuration between multiple server instances. Domain file contains the server profiles which we talked about in the standalone profile. The difference is that you can run the servers in server groups. You assign those server groups to a profile. If we have a look at the host file, it contains multiple servers which belong to a server group. If we start up a domain on this host, then we can see that multiple server processes are started. If we run the Java process in the background and then use the ps command to view the Java processes that we're running, we can see there are 4 running. They are the process controller, which controls the Java processes on this machine. The host controller, which controls the domain. In this case, this host controller is the master, and 2 server instances, server 1 and 2. So that's useful if you want to manage 2 servers running on the same host. There's also a host master and host slave example configuration files for if you want to run a domain controller on a separate machine and a slave controller on another machine. So in this case, I'm going to show you the host master, which is the master of the domain. It connects to a host controller on the local machine, which makes it the master. If we have a look at the domain controller section of the slave, then we can see that it points to the other host, the remote host. So it's a slave and the remote host is the master of the domain. It also contains 2 server definitions which use the main and other server groups defined in the domain XML file, which it reads from the remote host. So now we're going to run the domain and pass it the host config for host master and give it a management bind address of its external NIC so that the slave controller can connect into it. When we start the master this time, we'll see that the management interface 9999 is bound to an external NIC. That means our slave controller will be able to connect into it. So let's review the server processes that are running this time. There's a process controller which controls the processes and a host controller on this machine. So let's go to the remote host. If we have a look at the host slave XML configuration file, you can see where I've added the user host1 and its password. This is so it can authenticate to the domain master. The password is base64 encoded. You also have to add a section to the remote tag in domain controller, which is the security realm that you wish to use. So let's run the slave node. And I'm going to tell it which configuration I want to use, the host slave, and tell it the master address is the remote host. And after we start this server process, if we review the processes that are running using the ps command again, we can see that there are 4 processes running: a process controller, a host controller, and 2 server nodes. So that's how to run in domain mode. Deploying an application in standalone mode. I'm going to show you how to deploy an application using the management console when JBoss is running in standalone mode. So in the standalone deployment directory, there's a README text file which talks through the different deployment modes available. The default mode is that a scanner runs on the deployments directory and monitors new files. If you're deploying an exploded deployment, then you should use the marker files. This is to reduce the risk of a deployment being started before all the files are copied. In this case, I'm going to deploy a compressed WAR file, so I don't have to worry about that situation. To deploy a compressed WAR file, you just have to have the server started up. For the deployment scanner to be working, the service has to be started up. And if you copy a WAR file into the deployments directory, then it'll be automatically scanned and deployed to the server, like that. You can see the message in the server log. So then if I go ahead and remove that same file from the deployments directory, the application will be undeployed. And if we see again in the server log, yep, it was undeployed. So let's try now to deploy the application using the management console. So if I go to my browser and access JBoss running on localhost on port 9990, this is the management console. The first time you access this console, you'll get this splash screen which is saying that it's running but you don't have a user set up to access the admin console. It's a security feature of AS7 that we don't have any default users for the admin console. You specifically have to add one yourself using the add user script. You can find that in the bin directory of your JBoss installation. So to manage application, you need a user in the management realm. And it has to be a management user. So add a management user to the management realm and then reload the management console. This time when it comes up, you'll be able to log into the console using the credentials that you just specified. So admin and my password, which is JBoss. So once you're in the management console, you'll see down under deployments, there's a manage deployments link. If you click this link, you can add content and choose a file from your local file system. So I'm going to deploy the same WAR file which I deployed using the copy command on the command line. Simple app.war. So I just need to navigate to that location and select that file. Once I click next, that'll be added to the server. By default, it's not enabled, so you have to click to enable that application. And then if I check my server log file again, I can see that the application was deployed. That's how to deploy an application in standalone mode. Deploying an application in domain mode. If you have an application you need to deploy to multiple server instances, then you can use domain mode to deploy to those 2 instances at the same time. So in this console, I'm connected to one machine with IP address 10.1.1.10. And if I start up that machine, the domain master, and then start this other machine as the host slave, just reviewing the host slave, you see that there's 2 servers deployed to this main server group. If I start up a server on this other machine, and it will connect to the remote domain master, So once it's started up, then I'll be able to open the management console. This is the URL to connect to the management console. It's the same as running in standalone mode. Notice I used the master domain's IP address. So if you go to the deployment content tab under manage deployments, you can choose a file to upload to the server. Once you've uploaded it, click add to groups and select the main server group to deploy it to that group. Now that you've got it deployed to the server group, you need to go to the server deployments tab and enable it. And you can see in the server log from the slave node that the two server instances have the war deployed. And I want to show you how to do it using the CLI as well. So I'll remove that content now by disabling it from the server group and then removing the deployed content. So on this machine, this is actually my local machine. I'm just going to show you it's got a different IP address. So from this machine I can connect to the domain controller and its CLI port running on 9999. That's because I gave the domain master an external host, an external NIC to bind to so that I could access it remotely. So this is how I connect to the remote host from my local JBoss CLI. And I need to give it the credentials which I specified in a previous lesson, which have the management realm security context. The JBoss CLI is a powerful new feature of AS7. Commands can be run in offline mode or batch mode, meaning that you can program functions for AS7 to run and have them batch the commands all in one go. So now if I run help, I can get a list of commands and I see that there's a command called deploy. So if I run deploy, and here I'm going to reference a local file, and then I'm going to give it a server group which I want to deploy to, which was the main server group. And if I run that one, and then check back on my server log file on the slave node, I can see that my application's been deployed again. So that's how to deploy in domain mode. Sharing configuration in domain mode. I'm going to show you how to deploy an application to server groups in domain mode. Doing this allows you to apply configuration changes to a group of servers that may be deployed to multiple hosts. If I have a look at the domain XML file on the master node, I can see that I have two server groups. The main server group, which was there already, and the HA server group, which is using the HA profile. If I start up the master node using the host master XML configuration file, actually let's review the host master XML file. In it we can see that we've got the domain controller element is using local, which means that this is the master of the domain. So if we bind to the external NIC and also bind the management address to the external NIC, that means we'll be able to access the management console and CLI from a remote machine. Also, our slave node will be able to bind to this host, making it able to form a domain. On the slave, let's have a look at the servers that are deployed to this host. So there are 3 servers, 2 are in the main server group, and a 3rd server which is in the HA server group. You can see that we've added socket bindings so that the server's ports don't try and conflict with each other when they start up. A port offset of 150 means that all the ports will be offset by 150 from their defaults. Also on this host you can see that the domain controller is pointing to the remote host. We specify those arguments when we start up this server. They are the master address, and we're also binding this to an external NIC so that we can access it externally. So this time when we start up the node, it will start up 3 servers. And if we open the management console and access the master node on its IP address 10.1.10, then we can manage the servers from here. If we go to the Manage Deployments section on the left and click to add content, I'm going to add this simple app that I used in the previous lesson in this section and deploy it to the server. Before it's available to be used, I have to add it to a server group. So I'm going to add it to the HA server group, which only has one server on the 10.1.11 node. So I'm looking at its log, and you can see server 3 was pointed. Server 3 has logged that it's deployed the server, that it's deployed the application. So if I deploy it to the main server group this time, you can see that now in the same log, servers 1 and 2 have deployed the simple app. So that's how you can isolate different servers using domain mode and deploy applications to them without affecting each other. Similarly, if I remove the app from one of the server groups, such as the HA server group, I can see that in a log, server 3 has printed that it's now removing that content. So that's how to share configuration in domain mode. Deploying a database using JBoss Management Console. The reason for setting up a database in JBoss this way is to utilize the Java Connectivity API, or JCA. JCA adds connection pooling, which your database can utilize for better performance of the database. So let's first take a look at the database driver I'm going to use. In this case, it's a MySQL driver. And I can tell it's a modern JDBC4 compliant driver by looking in the files, seeing that it has a Java SQL driver file under meta-inf services. So if I run the server in standalone mode, and once it's started up, I access the management console. I'm going to deploy my JDBC driver, which I just showed you on the command line, first in the Manage Deployment section. And then I need to enable that deployment. After that, if I go to the data sources subsystem in profile, I can see what the connection URL should look like from the example data source. So I'm going to name my data source MySQL DS, and I'm going to give it a Jindy name similar to what I saw for the examples. Java:/JBoss/data sources. So I'm going to use that plus give it the name MySQL DS. The next step is to choose a driver. So I'm going to select the one that I just deployed, and then I'm going to set up the connection to my database. So you can read your driver manual on the connection URL semantics, but for MySQL it looks like this. Once I'm done, I can see my data source here, and I have to click to enable it. After that, under selection, I'll go to the connections tab and test the connection just to make sure it's all okay. So that's how to deploy a data source to JBoss using the management console. Deploying a data source using the CLI in standalone mode. I'm going to show you how to deploy a database using the CLI. So first I'm going to boot up a JBoss instance in standalone mode. And then if I switch to this second tab, I've already run the CLI and I've connected to that JBoss instance. Now I can use the deploy command to deploy the database driver. I'm going to use the same database driver that I used in the previous video, and it's a JDBC4 compliant driver. After I've deployed the application using its local file path, if I run the deployment info command with the name of the file, I can see that it's enabled and its status is okay. Now, if I use the data source command to read the existing example data source, I can see what kind of fields that I'm going to need to deploy my data source in the CLI. So there are things such as the connection URL and the Jindy name. I've already prepared a text file which contains the command that I need to run in order to deploy the data source. So here it is, data source add, and then I've got the name, the connection URL, driver name, Jindy name and username and password of the database. So if I run this command, then I'll be able to add my data source. There we go. So the last thing I want to do is I want to test my data source. So before that, I need to enable it. So let's use data source enable MySQL DS. And now I'll be able to test it using data source, test connection in pool, and the name again. And that returns successfully. So that's how to deploy a data source using the CLI. Deploying a data source using the configuration file. So there's a third way to make configuration changes to JBoss in AS7. They are the console, the CLI, and the configuration file. However, the configuration file should only be edited when the JBoss server is shut down. That's because edits made to the XML configuration file while the instance is running will be overridden by the server model. If either the console or the CLI make a change, you can overwrite changes made on the configuration file directly. You can read this in the official Enterprise Application 6 documentation, which AS7 is based off. So it's always recommended to shut down AS7 before making changes to the configuration file. So I'm going to add an XA data source to JBoss using this configuration file. So the difference between XA and a non-XA data source is summed up in this community article on the JBoss website. Local TX data sources or regular data sources are used when a transaction is contained within that one resource. However, if you have a transaction that's going to span multiple resources, such as a database and a JMS queue, then you should make sure that the database is defined as an XA data source. That'll mean that it's able to participate in a distributed transaction. So let's have a look at the configuration file. This is the data source that we added in the previous lesson using the CLI. And if we want to change this to be an XA data source, we can just change the name here to XA data source. However, if you try and start the server up now, throw an error about the connection URL not being valid. So we'll remove that and we'll add a couple of other properties. So these are the properties that are required for XA data sources. You can read in the docs schema folder, JBoss data sources schema file. This will tell you the properties that you need for an XA data source. So if I start up the JBoss server now, you'll see that the data source is deployed without errors. So there it is, starting deployment of MySQL connector, bound data source, Jindy. So that's how to deploy an XA data source using the configuration file. Connecting to a database from your application. I'm going to show you how to connect to a database from your application using a data source which is added in an earlier section. For this example, I'm going to use the Eclipse IDE with the JBoss Tools plugin installed. To install the JBoss Tools plugin, use this software site. I already have it installed. I'm going to use the Kitchen Sync Quick Start, which comes with the JBoss Tools plugin, to demonstrate using the database. Click New, go to Examples, go to Project Examples, and click Next. From JBoss Quick Starts, select the kitchen sink example. This example uses the Java Persistence API, or JPA. By convention, it uses a persistence.xml file which you can find in the meta-inf directory. We can see that in this example, it's already configured to use a data source. Notice also that this persistence XML file defines the Hibernate HBM to DDL.auto to be create drop. That means that each time you restart the connection factory, the database data will be lost and recreated. You definitely want to change this in the production system. This file by default uses the kitchen sink quick start DS, which is defined in a file shipped with this application. This method makes it hard to configure the data source, however, so we'll delete it and use our previously defined data source. We'll have to update the name to the name that we used. We can deploy our application to JBoss directly from Eclipse. In the Servers tab, click New Server Wizard. Select JBoss AS and make sure it's configured correctly for your environment. You need to make sure that the home directory is correct and it's using the correct configuration file. The Eclipse plugin for JBoss Tools only works with the standalone mode. Once you've added the new server, you'll be able to start it by right-clicking and hitting Start. In the Console tab, you'll be able to watch its progress. Once it's started, go back to the Project Explorer. From here, if you right-click on your application, you'll be able to select Run As and Run on Server to deploy it to the server. If we watch the console again, we can watch it being deployed. Just to make sure everything worked correctly, let's add a user. In the console, we can see that we've registered a user called Test. From the MySQL prompt, we use the JBoss database, which we defined for the application. Show the tables, and I think it will be in the members table. There we can see that our new user was created in the database. Configuring database connection pooling. You can configure the database connection pool in the Profile tab. Select the data source you want to change. Go to the Pool tab and click Edit. In this case, I'm going to set the min to 10 and the maximum to 30, and click to enable prefill. Enabling prefill means that the connections are created on startup. Click to save and then enable the database. You need to monitor the database, so in the Runtimes tab, you can see the connection pool usage here. If I select MySQL, you can see that we have 10 active connections because we've pre-filled 10. And I was doing some testing before, so you can see the max used at any one time has been 2 connections. Ideally, you'd want to use a load test, which tests similar to your production load so that you can see how many connections you actually need and adjust your pool size to match. You can also measure the statistics using the CLI. So if you run this command, statistics pool read resource, you can get some extra information like the max creation time, total creation time. All these settings are explained in this file. So in your JBoss distribution under the docs directory in schema, there's lots of schema files here which explain all the features of the application server. But we're particularly interested in data sources at the moment. So if you open this one, you can read about all the connections all the settings that are available, including the defaults. Deploying a messaging queue to JBoss. I'm going to deploy a messaging queue to JBoss using the management console. So in order to do messaging, I need to be running the standalone full profile. So I start up a server using the standalone full profile. And then I go to the Profile tab, and under the Messaging subsystem, I click Messaging Providers and click on the default to edit the default messaging provider. Under messaging providers, I go to the JMS destinations link and then click queues to add a messaging queue. So I'm going to give my queue a name, my queue, and then I'm going to give it a Jindy name. This is the name we use to look it up in JBoss. If I want an external JVM to be able to look up this queue, then I need to give it a name like Java JBoss exported. If I only want to use it from within the container, then I leave out the exported part, but I want this to be accessible from another JVM connecting via JNDI, so I give it the name exported. If we switch back to the console, we can see that the messaging queue was deployed. So that's how to deploy a messaging queue to JBoss using the management console. Hello, in this section I'm going to teach you how to use a messaging queue. I'm going to use a messaging queue that I deployed in an earlier tutorial. First of all, make sure you're running in the full profile. I'm going to use Eclipse, so double click on the server in the servers window, click Runtime Environments, and make sure your configuration file is pointing to one of the full profiles, so standalone full or standalone full H8. Okay, so I'm going to start my server. You can watch the progress in the console tab. Once it's started, I'm going to verify that I have my queue deployed. We covered this in a previous section. So under profile, if you go to messaging provider, default and view, and then under the JMS Messages tab, you'll see that hopefully you have my queue deployed, and this is going to have to be in the JBoss exported namespace for it to be accessible by clients outside of the container. So yeah, going to a client that's outside of the container, I've written a client here called QSender, and this is going to be a message producer. It's going to connect to the queue running in JBoss, and it's going to send a message. So it uses only the JavaX, JMS, and JavaX naming namespaces. It has no specific dependency on JBoss. It has basically one method called send, and in that method it connects to a queue called myQueue, going through this remote connection factory. So I had to set up a user called test user with a password. That's because in the standalone full configuration, there's a section in here called security settings. Now by default, all the queues are secured, and only a person with a role guest can send or consume from them. So we have to create a user that has this role guest. So I'll show you how to do that. The easiest way to do that, in the bin directory, there's a script called add user. So make sure you create it in the application realm. So I'm going to use test user and give it a password. And for this section, this is where I have to make sure that it's got the guest role. And I've already created this user while I was testing, so it already exists. So now that I've created that user, I'll be able to use my application queue sender to send a message to the queue. And so I look up the connection factory. From the connection factory, I create a session, and then I create a sender and give it the queue name and a text message, and that's my simple program. So this program has one dependency, which is the JBoss client jar. You can find this in the bin client directory of JBoss installation. So I'm just going to use Eclipse to run it after adding that dependency. So if I click Run as Java Application, it'll launch the application and my message was sent successfully. We can verify that it was sent successfully in the console. So switch back to the Runtime tab, go to your queue, and here's where you can see the number of messages in the queue. I've got one message in my queue, and I'll run that again. Now I can see if I refresh that I have 2 messages in my queue, so my messages are being sent successfully. So that's how you connect to the queue from outside the container. I'm also going to show you how to connect to the queue from inside the container. So also part of my project here, I've written a message-driven bean. Message-driven bean is part of the EJB specification. You configure it like this. You give it the queue name here and which connection factory to use. This connection factory is also defined in the standalone full.xml file. So if we go looking for, yes, JMS connection factories, there's an in-VM connection factory. That's the one I'm using because I'm going to deploy my message-driven bean to the container so it can access it in the virtual machine. You can also use a remote connection factory if you're connecting from outside, an XA connection factory if you want to use distributed transactions. So in my case, I'm going to use the in-VM connection factory. Message-driven bean implements message listener, which has an on-message function. Now this gets called every time a message is delivered to the configured queue. And all I'm going to do when I receive a message is I'm going to print the message. So if I deploy this to my container, by selecting Run As and Run on Server, select JBoss, and you can see that it's deployed, and straight away I've consumed 2 messages off the queue. Those are 2 messages that I sent earlier. So just to verify that everything's working correctly, if I run the sender again, you should see that it's triggered successfully. And if I switch back to the JBoss window, I can see that there was a new message sent. That's how to use the JBoss messaging. I want to talk about the JVM and garbage collection. While I'm going to talk about the Oracle JDK in this section, it also applies to the Open JDK. JRocket is also another JDK which is quite similar, but the terminology is a little bit different. Unless your application has rather strict pause time requirements, first run your application and allow the VM to select a collector. If the performance still does not meet your goals, then use the following guidelines as a starting point for selecting a collector. But probably the only one that you want to actually specify, I think, is this use concurrent mark sweep GC. This is used for when you want to minimize the amount of pause times that your application has. Maybe for a stock trading application that can't afford to be unresponsive for a period of time. So I'm going to move over to this Memory Management White Paper 150-15 on the Oracle website. So the Java heap is broken up into several sections. Young generation actually includes Eden and Survivor spaces, and the old generation. So this is the heap memory. So as you can see here, objects that have no longer being referenced by other objects become eligible for garbage collection, and that's where they're marked with an X. If they're still referenced, then they're moved into one of the survivor spaces. And objects swap between the from and to survivor spaces several times, and if they're still being referenced after a relatively long period of time, then they're promoted to the old generation. Unless, of course, you run out of old gen memory, and then you're really in trouble because you're going to get an out of memory exception, the concurrent mark sweep collector. And what this does is it reduces the pause times. As you can see with the serial mark sweep compact collector, there's a long pause time. And if you want to avoid this long pause time, then you can use the concurrent mark sweep collector. In the initial mark, the pause time is minimal, and then there's one thread that's dedicated to garbage collection through the processing of the application, and a remark happens on multiple threads, and concurrent sweep continues in a parallel thread. So if you decide to use concurrent mark sweep, you can set the properties using the standalone.conf file for standalone mode or domain XML file for domain mode. To use concurrent mark sweep in standalone mode, edit the standalone.conf and add the JVM parameter for this part. Notice that I'm adding it right after where you set the maximum heap size. In domain mode, in the host XML file under default JVM, add it to the Java ops value here. Now for setting the max heap size, go to the standalone conf file, which is in the bin directory. Standalone conf is for Linux machines or Mac OS as well. Also, standalone.conf.bat is the one you edit if you're on Windows. So since I'm running on Mac, I'm going to use the standalone conf, and you can change the maximum heap memory size by this setting here. Just change this number. And for the minimum heap size, set this number here. In domain mode, the domain XML file defines a server group. So your server will be running in a server group, and that server group references a JVM name from the host XML. And then what it's done here is it's overridden the settings from the host XML file. So this is the actual settings that will be used in this case. If we didn't have these heap sizes here, however, the default sizes from the host XML file would be used. In the host XML file, it's also possible to specify a JVM setting for a particular server, not just a server group. So as you can see, server 2 is a member of other server group. But if you want to specify a max heap size for only server 2, then you can add a JVM element to the server tag and specify a max heap size here. So that's how to select a collector and set Java heap size on JBoss. Hi, I'm going to teach you how to enable garbage collection logging and enable heap dump on out-of-memory error. These are two very important diagnostic tools that have very minimum overhead for production systems. So it's safe to run these in your production server and it won't cause a lot of performance overhead. And the benefits that you'll gain from it are immense, so I recommend this to all users that are running JBoss production. So the first is to enable garbage collection logging. In standalone mode, you edit the standalone conf file, and these are the options you need to enable garbage collection logging. The second one is Java heap dump on out-of-memory error, and you can see the options you need in the second option here. So if I run in standalone mode, you can see in the output here that we've got all those options enabled. And if we check the GC log, it's in the home directory. You can see our GC logging. I'll explain what this actually means in a later presentation. If you're running in domain mode, then you'll have to edit the host XML file. And the JVMs, there's a default profile for the JVMs, and if you add these options here, it'll have the same effect. So again, if I shut down standalone mode, run in domain mode, then it won't show the options here because these are the options for the actual host controller. I'll have to wait till it's booted. Now if I run ps grab Java, I can see for server 1, I can see the options here. And for server 2, which also uses the default JVM profile, I can see the options here. If you want more information about the debugging options, then check out this article on the Oracle website. I'm going to talk about how to capture a Java thread dump and when and why you would do this. The most obvious reason you would capture Java thread dump is if your JVM is locked up. Your application becomes unresponsive and the JVM is still alive. So there are various tools in the JDK to do this. In order to use the tools, you've got to make sure that you have the JDK bin directory on the path. I'm using Linux in this case, so I can set the path in this. You can see here that I've used this command to add to the path variable, and I've included the JDK 1.7 bin directory. Now, in the bin directory are various tools for JVM diagnostics, such as JPS. JPS prints the current Java processes that are running for the current user. So at the moment I'm logged in as a user JSINner, and I've got 2 Java processes running. So if I want to know if my JVM has crashed, I need to check if this JBoss modules process is still running or not. If it's still running, then we'll be able to capture a Java thread dump. Application unresponsiveness can be caused by long garbage collection pauses, so you should definitely have GC logging enabled, as I showed you in the previous video. So first check the GC for long pauses. The second thing you should do is you should run top. Top tells you which processes are using CPU MM. So you can see in this case that the Java process is using 12.5% of the memory and 0.3 of the CPU. JBoss is not causing high CPU in this case. So I'm going to capture a Java thread dump to see if it might be some thread locks or thread contention that's causing my JVM to be unresponsive. So to do that, we're going to use the JStack command. JStack has various options. It works by passing the options and then the process ID to the command. The -L command prints long listings, which is additional information which is quite useful. So I'm going to use JStack, the -L command, and pass it my Java PID. If I use JPS, I can see it here again. I'm going to use the JStack command with the -L and pass it my process ID, which I looked up using JPS. And I'm going to output to jstack.out. Now if I check that file, I can see I've now got a Java thread dump, and I can see what all my threads are doing at the time. So the second thing I wanted to show you was if you have high CPU. Now if your CPU is 100% or more, then you probably want to capture the top output as well. So in this directory, and I'm going to hand this out as well. So let's have a look at this script. This captures a series of top output. You can see here's the top command that it does. Unfortunately, if you're running on Windows, the top command won't be available to you. You'll have to use the Process Explorer to monitor CPU per threads. That will make this script unusable for those using Windows. Prints the current timestamp and then uses JStack, just like I did to print the thread dump. And this, by default, loops 6 times with 20-second intervals each time. So you can adjust those interval times, but this is a good default. Check the Java process, run the high CPU, passing the process ID. So if I check in these files that it's generated the high CPU out file. And this is like the top command we saw before, but it was a snapshot. And it's also printed the date at the top. We can see the thread dump at the same time. This is going to be really valuable to let us know which Java thread is causing the high CPU. And I'll show you how to do that in a later video. I'm going to show you how to analyze some garbage collection logging. In a previous video I showed you how to turn it on, so now I'm going to show you how to analyze it. You can see that I've got my GC log open here, and it's basically got 2 kinds of information. These lines are the minor collections, and this is an example of a full GC collection. So in the minor collections, not all the survivor spaces are collected. PermGen is not collected, and the tenant generation is also not collected. So it's usually not that useful, the minor collections, so I'm going to basically skip over it. But the only time you'd be concerned is if there are many minor collections. Then it's an indication that you might have to increase the size of your young generation spaces. So what I do want to look at is these full GC lines, and to make it a bit easier for us to read, let's open it with grep. I'll use grep just to show the full GC lines. So the tenant generation, I'm just going to show you the graph that I showed you in an earlier presentation. So the tenant generation is also referred to as the old generation. It's the space that the objects are promoted to once they survive all the young collections. So you can see here the first number is the size of this generation before the collection, and then this number is the size after, and this is the total size of the generation. So this is the same thing, but this is the total heap size, including both of the young survivor spaces. And this is for the permanent generation. So probably the key numbers here are these numbers, which are space after the collection. So if you're running out of heap space and you find that these numbers are continually increasing without ever decreasing, as they do in this number and this number compared to 19699, then that's an indication that you might have a memory leak in your application. In that case, then you can use heap dumps and heap dump analysis to find out what the memory leak is. So there are also visual tools you can use, such as GC Viewer, which will print out a nice graph of your GC logging, which can be very handy in some cases. So that's how to analyze garbage collection logging. I'm going to show you how to do a basic thread dump analysis. In a previous video I showed you, if you had high CPU, how to run the high CPU capture script. Here I've run that script on a JVM that was getting high CPU. And in the high CPU.out we can see that there's one thread causing the high CPU. You can tell that because it's got 100% of the CPU and none of the other threads do. So if I wanted to find out which Java thread this process was, then I could use a scientific calculator to translate the base 10 number into a base 16 number. I plugged in the native PID 2153, and if I change that to base 16, I can see the base 16 version of that. Now if I search for that in the console.out, which captured my Java thread dump, I can see the native ID and I can see what the thread was doing at the time. So in this case, the high CPU seems to be caused by some log4j code. That way I can narrow down what was happening in the JVM and which Java thread was causing the high CPU. Samurai is a useful tool for helping to analyze thread dumps. You can download Samurai from this URL. It's an executable jar, so once you have it downloaded, you can use a command like this to run it. So I've already got it running, and I've opened the thread dump which I showed you just before. So in the table view, you can see a list of all the threads, and in this case we've used our script which captured 6 thread dumps. So the arrows indicate that in the previous thread dump the thread was doing the same thing. So all the ones with the arrows are either stuck or just waiting. In the table view, some threads might show up as red. This indicates that there could be a problem. It's either locked or has thread contention with another thread. So Samurai is useful because you can view in a table view like this and ignore threads that are either gray or green. If you click on this button, it'll take you to the thread dump view. The thread dump view will show you one of the thread dumps, which list all of the threads that were running at that point in time. This is how you would see the threads if you were looking at the actual file. But the beauty of using Samurai is, if you click on any one of these particular threads, it'll take you to a sequence of that thread over the 6 thread dumps. This is a quick way to see whether this thread has made any progress during the time that you were capturing thread dumps. This kind of task would be quite hard if you were using the straight text file alone. So that's how to analyze a Java thread dump. Analyzing a Java heap dump. In an earlier video I showed you how to capture a Java heap dump. In this video I'm going to show you a brief introduction into how to analyze it. I'm going to use the Eclipse Memory Analyzer tool. You can find it at eclipse.org/mat. You can download it here. You can also find documentation. So I've already started up mat. And I'm going to open my previously acquired heap dump. Heap dumps generated by the Sun JVM end in a .hprof extension. With mat, you'll be able to open OpenJDK heap dumps and Sun JDK heap dumps, but you won't be able to open IBM JDK heap dumps. IBM have their own tool for analyzing heap dumps. So there are a couple of reports you can generate. The most useful report is the leak summary report, which will tell you if you have a heap memory leak. So now my heap is loaded, I can open the leak suspect report and I can see this pie graph here. I've got one object which is dominating my heap. That's problem suspect number 1. And if I scroll down, I can see that problem suspect number 1 is this class, zookeeper properties, and it's occupying 96.2% of my heap. So I think that I must have a memory leak of this object that's not being garbage collected. If you want to find out more, you can click on the details and you can see the path to the garbage collection routes. So these are the objects that are keeping this object in memory. So if we use the histogram feature, it'll list classes that are dominating the heap. We can see the largest object is this zookeeper properties class, which we saw in the leak suspect report. Now, if we list outgoing references, it'll load the objects which are referring to this class. And I know with a class that it's going to return a list of objects of this class type. Now this is a peculiar list because all of the objects in the heap have the same size and there are 260,000 of them. So let's have a look at one of these at random and we can see that there's something meaningful in there. It's a fabric authentication users. You can see it in the details pane on the left hand side. So let's have a closer look at this particular object and try and see what's holding it in memory. If we do pass to GC roots, it'll show us pass to the root GC, which is holding this object in memory. Now, some interesting things here are that there is a QTP thread, which is a Jetty client or Jetty HTTP connection. I just know that from experience. You get to know these things if you look at threads very often. So now if we use the Java Basics thread overview to look at that particular thread, we can have a look at the call stack that it was using when the heap dump was collected. So in this call stack, we can see that there's a zookeeper client context which is submitting a request. So we can safely say that this class was doing some work and it was passing around a large set of objects, all of the same. So at this point, we're ready to go back to our developers for further analysis to see what they think about this problem. Another feature I want to show you is object query language, which can be used to do SQL queries on the heap. If you look in the help contents page, you can see some documentation on the OQL syntax. So let's try using the select clause to get more information about a particular class type. So I'm going to use the zookeeper properties class, which we've been talking about so far in this lesson. So we can use an SQL syntax like select star from and then put in the class name. This will select all the objects of the particular type. And conveniently, there's a built-in feature for auto completion of the existing classes in the heap. So if we execute this query now, we can see that we get our 2,600 objects we've been seeing so far. And we can also use our query to get a particular field within that object. So we could change the return type to be of P. So we'll get zookeeper properties object back, and then we can select the path from that. So let's have a look at another heap dump. This time I'm going to focus on the dominator tree. So if I click on this icon, I can open the dominator tree, which lists objects by their retained heap. You see at the top the largest object. I know I can ignore this object because I know it's just pending VM cursor, which means it's a bunch of messages that are piled up on the queue. But I'm really interested in this second object because it seems to be a large character array or string in memory. It's quite a large object, 135 megabytes. If I click on that object and list path to GC roots, I can see the objects that are keeping this character array in memory. And again, I can see a thread here, which is the QTP or Jetty HTTP connection pool, which is keeping this object in memory. If I right click that QTP thread and view thread overview, I'll be able to see a complete stack of that thread. And this thread is quite interesting because right at the top of the stack is the out of memory error, which actually generated this heap dump. And I can see it's trying to copy this large character array of 134 megabytes. And if I go down a bit further, I can actually see the buffer that was contained in memory at the time. And if I right click on that object and copy, I can actually copy the string contents into my buffer, and I've pasted them here into a text file. So I can narrow it down to the request that was being printed out at the time by this Jetty HTTP connector thread. So that's how to analyze a Java thread dump. Clustering in standalone mode. I'm going to show you how to set up a cluster of 2 nodes in standalone mode. I'm running the 2 nodes on separate hosts. Here's host 1 and its IP address ending in 228. So I'll start in standalone mode on this node. Notice that I'm using the standalone HA profile. It contains the subsystems required for clustering. I'll also have to bind to the external NIC so that the other node can access this node. I'm also specifying the JBoss node name, which is not strictly required because if you don't specify it, it'll use the host name of the host. The other thing I'm doing is I'm specifying a multicast address. This is the default multicast address, so it's not strictly required either. However, if you're running multiple clusters on a network, you'll have to make them unique by specifying the multicast address. So let me start this node. While it's starting, I'll switch to the second node and start it as well. This is the same, only I've changed the bind address to be this machine's NIC, 29 address, which is listed here, and I've changed the node name to node 2. If I switch back to node 1, I can see that it started. Now, it hasn't actually formed a cluster yet because the clustering subsystems haven't started. I have to deploy a clustered web application before the HTTP sessions are replicated, and in order to do that, the JBoss instance have to form a cluster. So if I have a look at a clustered web application, which I've written here, clustered web app, in the webinf web XML has this distributable tag. So if I deploy this application by copying it from my Mac onto first node 228, I should see it deployed in the log. There it is being deployed, and here's where my clustering subsystems begin to start. So this line indicates it's starting up the clustering subsystems, and so this line from JGroups saying that it's received a new cluster view, and at the moment there's only one node in the cluster. But if I go ahead and copy my clustered application to the other node, whose IP address is ending in 29, if I watch its log, you can see the deployment is started, the clustering subsystems are started, then you can see we've received a new cluster view, and this time there's 2 members in the cluster. It's important to note that in standalone mode, you'll have to copy the clustered application to both nodes in 2 separate operations, but if I was running in domain mode, I'll be able to use a single farm deploy method to deploy to both nodes simultaneously with 1 operation. So that's how to set up a cluster of 2 nodes in standalone mode. Clustering in domain mode. I'm going to show you how to set up a cluster in domain mode. On this tab, I have a server which has the IP address 10.1.1.10. This is going to be the master of my domain. I've already edited the domain XML file, and this is what I've changed. So let's have a look at the domain XML file. You can see here I've added a server group which is called HA server group, and it's using the HA profile. The HA profile contains various things which are required for clustering, such as JGroups. You can see the subsystem here, JGroups, and it's using UDP stack. You can see there's a UDP or a TCP stack. By default, it uses UDP. The InfiniSpan subsystem defines several caches by default. They are the cluster, web, and EJB cache. So the cache that we're particularly interested that is going to be holding our HTTP session state between nodes in a cluster is this web one. So this is where you can configure the HTTP session cache. Know by default that the settings are quite good and you probably want to stick with the defaults. So let's have a look at the line I'm going to use to run the domain XML file. I've already showed you how to set up a domain in a previous lesson, but I'll review it here because it's rather complicated. So you can see I'm passing a host config file, which is the host configuration. I'm binding it to an external NIC, and I'm also setting the management address to that external NIC. And if I review the host master XML file, you can see that I've added a few things. One of them is I've added one server to the master, which is server 1, and it's using the HA server group. And I've also added the two management interfaces that are missing by default from the host master XML file. That's because I wanted to actually run a server and not just act as the domain controller, the master controller for the domain. So again, here's the line I'm going to use to start up the server. Making the JBoss management address an external NIC does pose a bit of a security risk. So you might not want to also expose your management console to an external address. You might just want to expose the CLI or 9999 port. You can see when I start that up now, the 999 port is running on that external NIC. That means I'll be able to connect my slave into it. So if I review the host slave XML file on the second node, I can see I've removed the two servers and added one that uses the HA server group. So I've got two server instances, one on each node, and both using the HA server group. I've also added host 1 as the host name and added the base64 encoded password to the management realm. That's so I can connect the slave to the master node and have it authenticated. So this is the line I'm going to use to start the slave node. You can tell that it's telling that I want to use the host slave as my host configuration. I'm going to tell it the master node, and just for completeness, I'm going to also bind this node to an external NIC so I can access its deployed applications using a load balancer, etc. So once I've started up this node, I'm going to connect to the CLI on the domain master, which is the 10.1.1.10 node. Let's just review where I'm connecting from. I'm actually connecting from a third machine, which is my desktop running the Mac OS. So from here in my JBoss installation directory, I can run the JBoss CLI script and then connect over to the domain master, which has the CLI or the 999 port bound to an external NIC. I need to authenticate to it, so I'm going to use the admin credentials, admin and JBoss, and then I'm going to use the CLI to deploy a clustered application. That a clustered application has a distributable tag in its web.xml file. So I can use tab complete in the CLI to choose the WAR file and then specify the server group that I want to deploy it to. I'm going to use that HA server group, which has the subsystems required for clustering. When I do that, I can see that suddenly my server instances are going to form a cluster. That's because they have an application that requires clustering, so they're going to enable those subsystems. If we take a close look at some of the lines here, one of them specifies that we've got a new cluster view. It's from InfiniSpan, and it's saying that we have the master is server 1, and the host 1 also has a server called server 1. And that's how to set up a cluster in domain mode. I'm going to show you how to use mod cluster as a load balancer for your JBoss cluster. First, you have to download the binaries for your operating system. There are many binaries available, but if you notice, there's no 64-bit Mac OS binaries, which is why I didn't use Mac OS in this example. What I did use was I used Linux, the x86 version. So I've got Linux installed in a virtual machine. I'm going to open up a console. So this is the same host where I'm going to run Apache and JBoss. So I'm going to have a look at the HTTP configuration file on this node. If I go up to the modules section where I've added the modules, you can see these are the modules that are required for mod cluster. I also had to disable this module that ships by default with my version of Apache because it conflicts with these mod cluster modules. Now if we go to the bottom of the file, I've added a couple of things to enable mod cluster. They are the mod cluster manager, which is the management console used to monitor mod cluster. I've added a listen directive, which this is an external NIC accessible from the JBoss instances. And then inside a virtual host directive, I've added allow all, but you might want to make this a subnet where your JBoss servers are. Also, it's important to note if you want to use server advertise on JBoss 7.1.1, you have to add the advertise security key, which is here. If I exit the configuration and restart Apache, now if I access this Linux server which is running Apache, I try to access the manager file, I'll see that mod cluster is running but there's no servers added yet. And if I try and access my application, then you'll see that it's not available because the JBoss server hasn't started yet. And I'll show you how to add JBoss instances to the mod cluster setup in the next video. Before you run a JBoss instance, you can check whether multicast works on your network using the advertise tool, which ships in the mod cluster source code. You can download it from this URL. Have a look at it. It uses multicast socket and listens for incoming advertisements from mod cluster running on Apache. So I'm going to run it on the remote host, which is not running Apache. If I run just Java advertise, it'll give me some sensible defaults to run with. So if I run with those, it'll start listening, and you can see that I'm receiving packets from my node which is running Apache. So multicast seems to be working correctly on my network. So that's how to set up mod cluster to load balance between JBoss applications. How to set up JBoss to work with mod cluster running on Apache. In a previous video, I showed you how to set up mod cluster on Apache as a load balancer for a JBoss cluster. Now I'm going to start up 2 JBoss instances running in domain mode with a mod cluster subsystem configured to work with that mod cluster instance. So here's one of my nodes running on the same host as Apache. That's just for convenience. It could be running on a different host. So I'm going to show you the domain XML file. So here's the HA profile, and if we look for mod cluster subsystem under here, you can see that I've just added one field which wasn't there by default. That's the advertise security key. Due to a bug on JBoss AS7.1.1, you need this advertise secret key. It's the same key that I specified in the previous video on the Apache side. There is another thing that you'll need, which is a JVM root. Well, it was known as a JVM root in previous versions, but in AS7, it's in the web subsystem and it's known as an instance ID. So since the domain configuration is shared between both nodes in my cluster, instead of specifying an actual name, I'm going to use a token which is JBoss node name. And this is replaced dynamically for each host running in the cluster. So that's all I need on this node, and I'm going to start it up. Note that I'm specifying I want to bind to an external NIC, so Apache can send a request to me. And I also want to specify the node name, in this case node 1, and the bind address for the management interface. I need this for clustering to work. So when it starts up, JBoss is going to advertise itself to the Apache proxy server, and it's going to tell Apache what applications it has deployed. It's also listening for advertisements from Apache and Mod Cluster, so you can add Apache instances and remove them dynamically. So first I'll try and send a request to my clustered web application, going through my proxy server. Notice that I don't specify the port because the default port is the Apache one, port 80. Also, if I check the Mod Cluster Manager application, I can see now that I've got one node running on the cluster and it's running a clustered web application. So let's start up the second node in my cluster. No changes needed in configuration on this node because it pulls the configuration from the domain master. Just when I start up, I just specify a different JBoss node name. And I also specify the master address for JBoss clustering. So this will go ahead and advertise itself to Apache and let it know what applications it has deployed. So let's check my Mod Cluster Manager application again. You see that I now have another node, a new IP address, and it also has the clustered web app. So let's test again, sending a request to the application and check the logs for what server that landed on. So this was node 2 and this was node 1. Notice the 228 address. Now what I can do is I can shut down this node, send another request through my proxy server or mod cluster. You can see that I've still got the same session ID, so it still knows who I am. And if I check my server log, obviously this was served by my other node. So that's how to set up mod cluster for load balancing of web applications. Introduction to JBoss modules. I'm going to show you the new modular class loading system in JBoss. If you've used JBoss 5 before, then you've probably run into a few problems where the classes from the application server have been available in your application, but you didn't want them to be. Or you wanted to use a different version of the class in your application which was packaged as part of JBoss, and you didn't know how to. So with the new system, these kind of problems can be overcome easily. The first thing I want to show you is this part of the jboss.org documentation. It talks about the class loading precedents. Class loading precedents is broken up in 4 levels. They are system dependencies, which are part of Java EE, or the JBoss container. 2, which are user dependencies. And these are dependencies that are added through the JBoss deployment structure XML or through other metadata. The local resources, which are the classes that are actually packaged with your application. And number 4 is interdeployment dependencies. So these are dependencies of a nested jar or a nested WAR file in an EA. The other thing I want to introduce you to are implicit module dependencies. This part of the JBoss community documentation has a table which lists the implicit module dependencies and the trigger conditions which cause those dependencies to be loaded. By default, you get access to these packages, which are loaded as modules. For the web subsystem, if you meet any of these trigger conditions, such as deploying a WAR archive, then you get access to these packages. If we have a look at this diagram, we can see more clearly what the JBoss modules class loading looks like. So I've got my theoretical web application here, and by default, I don't have access to these classes which are contained in the application server. However, this is a WAR file, so I'll get an implicit dependency on org JBoss AS Web. Org JBoss AS Web also has a dependency on org JBoss Common Core, but my application won't get access to that module because it's not listed as being exported by org JBoss AS Web. Let's have a look at this on the file system. So in the modules directory, that's where you'll find all the modules. And I was talking about org JBoss AS Web. So let's go to that directory. In that directory, there's a main and module.xml file. This module XML file describes the module. You can see that it lists the jar files which it includes as resources from the file system. You notice that this module also has a property called JBoss API private. What that means is if you try and use this module directly, you'll get a warning in the log file saying that this is private and you might not want to use it directly. Also, if we go down to the dependencies section, you can see what I was talking about in the diagram, that this class includes org JBoss common core, but it doesn't add an attribute exported, which would make it also available to my web application. This was an introduction to JBoss modules for class loading. Implicit module dependencies in JBoss. I'm going to run you through some of the implicit module dependencies in JBoss and how to work with application metadata to exclude modules which are implicitly loaded. So let's have a look at this page from the jboss.org documentation. It lists all the implicit module dependencies and the trigger conditions which cause those dependencies to be added. So you can see by default we get access to all these modules. And if we deploy an application which meets these trigger conditions, such as an EJB jar XML or these EJB annotations, then we get access to the Java EE.API module. Similarly, for JPA, if we deploy an application which has a persistence unit or persistence context annotation, then we'll automatically get access to these modules. For a WAR archive, we get access to these modules. And for a CDI application, it includes a beam.xml file, which implicitly gives us access to all these modules. So let's have a look at the JBoss deployment structure XML file. You can find that at this page in the documentation. This file allows you to adjust the implicit module dependencies. So you can use it to prevent automatic dependencies from being added, add additional dependencies, define additional modules, or change an EA deployment isolation class loading behavior. You can even use it to add additional resource routes to a module. So let's run it through a hypothetical situation. Imagine you had an application net JSON-shepherd.web, and that application had the JPA persistence unit annotation, which meant that it automatically loaded JavaX persistence API. And JavaX persistence API had a dependency on org hibernate, but you wanted to use an org hibernate version that was packaged in your application. You could use the JBoss deployment structure XML file to explicitly exclude org hibernate from being loaded by the application server. So this is how you would do it. In the JBoss deployment structure XML file, you include an exclusions tag which had your module name that you wish to exclude. So that was about implicit module dependencies in JBoss. Including and excluding JBoss modules. I'm going to show you how to include and exclude modules from JBoss by using metadata in your application. Before I do that, I'm going to introduce you to the concept of module versioning. Let's start by looking at the JSF import module. In this directory, you can see there's two subdirectories, a main and a 1.2. If we have a look at the main directory and the module.xml file which describes the module, we can see that it includes version 2.1.7 of the JSF jars. So if we go back to the previous directory and have a look at the folder 1.2, we can see that in its module XML file, it includes versions 1.2 of the JSF jars. If we go back to the implicit modules dependency page, we can see that when we deploy a WAR, we automatically get a dependency on the com/sun JSF import module. So I've got an application here which uses JSF 1.2. And if I try and deploy this to the server without making any changes or adding any metadata, I can see that when it starts up, it throws some errors. The exact error that it throws is this one. Could not find factory application factory. This is because it's trying to use JSF2 when I've written my application for JSF 1.2. The way to get around that is to include some application metadata. And you can see that I've excluded two modules from being loaded by the application server, the JSF import and one of its dependencies. I've also included an explicit dependency on version 1.2 of these modules. Now if I copy this JBoss deployment structure XML file into my application. Note that because it is a WAR file, the JBoss deployment structure XML has to go into the webinf directory. If this was an EAR file, it'll have to go into the metainf directory of the root. This time, pick up the JBoss deployment XML file, and it'll exclude its default JSF import class and include the 1.2 version as I've explicitly declared. You can see that my application was deployed successfully this time. So that's how to include and exclude module dependencies using JBoss. Class loading in an EAR file. I'm going to use the JBoss AS7 configuration, deployment, and administration book published by Packet Publishing to help me explain the concepts here. So in an EAR file, each sub-deployment is treated as a module, and by default they're isolated. So how does a class loader figure out which classes to load within an EAR? So they're defined in this order. The maximum priority is given to modules from the AS server. Then libraries that are indicated by the metainf, such as manifest.mf or JBoss deployment structure XML, are given preference. After that, libraries that are packaged with the application itself, such as classes in the webinf lib, are prioritized. And finally, libraries that are packaged in the same EAR archive, for example in the EAR's lib folder. If we have a look at this example application, it contains an EJB EAR and EJB jar in an EAR, which simply prints hello given a name. I've changed it so it says hello from EJB so we know which code is being called. And if we build the application using Maven in Eclipse, we can set up a target which defines the Maven goals we want to run. In this case, just clean, package, and JBoss AS deploy. And we run that. This will deploy to JBoss and so that we can send a request into our EJB and see what it prints. So this EJB application contains a WAR file. And so I need to open up my browser to send a request to that WAR file which calls the EJB. And you can see that my EJB has returned hello from EJB, as we expected. But what if we also have a greeter EJB within our WAR file, which is in our EAR? Which code is it going to call? Is it going to call the code in the WAR or the code in the EJB? Well, there's one way to find out. Let's copy the package into the EJB, change the code a little bit so we know which code we're actually calling, redeploy our application and try again. If we recall from our previous book, the classes that are packaged in the webinf classes directory are going to have preference over those in the EAR. So our application should print hello from WAR. We resend our request and sure enough it says hello from WAR. But what if we wanted to change this behavior? What if we wanted to override the class from our WAR from the one from our EJB jar? Well, we could do that using the JBoss deployment structure.xml. And in an EAR file, that's placed in the metainf of the root folder in the EAR. So let's go ahead and create a metainf folder and copy our JBoss deployment and create a JBoss deployment structure.xml file in that directory. So I'm going to use this JBoss deployment structure XML which I deployed earlier. Notice that it adds an EAR subdeployments isolated false so that the subdeployments can see each other. This is the default configuration, but I just added it to be explicit. Next, we want to operate on the WAR file. So you notice that I give it the same name as it has in the EAR. There it is there, JBoss AS EJB in EAR web.war. This allows us to define class loading for that particular EAR. So what we want to do is we want to add a dependency on our EJB jar. And we reference it like this: deployment, then the EAR name, then the jar name. So if we redeploy our application now, we should see that the class from our WAR file is not used, but the one from our EAR file is used. While this is a rather convoluted example, it does demonstrate the kind of functionality that you can achieve, and the powerful class loading detail you can get into with the JBoss deployment structure.xml file. So if we switch to our console, we can see our EA is being deployed. And if we jump over to our web browser, well, actually, let's first check the contents of the EA to make sure our JBoss deployment structure went into the right place, and there it is under metainf. So let's test our grid application now by sending another request with our name, and you can see that the EJB is now being called. So that's how to do class loading in an EA file. Using asynchronous servlets in JBoss. I'm going to show you how to use asynchronous servlets, which is part of the Servlet 3.0 specification. The Servlet 3.0 specification came with Java EE 6, which JBoss implements. So first, I want to show you this table on the Tomcat website. JBoss AS7 includes a component called JBoss Web 7. It's based on Tomcat 6, but the information in this documentation is relevant to JBoss Web. So you can see in this table that it compares three different connectors. One is the Java blocking connector, the Java non-blocking connector, and the APR native connector. So the one I want to show you is the Java non-blocking connector. You can see that it has more non-blocking operations than the other two connectors. Traditionally, you could improve performance by using the APR native connector, which has non-blocking support for wait for next requests, but Java non-blocking connector has more comprehensive support. So I want to show you a diagram of what a request lifecycle looks like with the default connector. So a client browser initiates a request and stays alive for the duration of that request. A thread is checked out from the connection pool and is maintained for the life of that request. So any work that you do in that request, such as calling an external web service, is a blocking call because thread stays alive for the duration of that request. So if we compare this to the asynchronous servlet connector, we can see that the client browser still spawns a single thread and that thread stays alive for the duration of the request. But in this case, when the request is passed to the HTTP connection pool, a thread is checked out from the pool, and then you can, with the servlet specification, you can pass that request on to a new thread pool, which then executes your work in a separate thread. In this case, calling an external web service. This frees up the HTTP connection pool to handle another request. So I've written a small application which uses asynchronous servlets. First, I want to show you the synchronous servlet, which is a traditional way of handling requests. So in this case, I'm just getting the writer from the response object. I'm parsing the postcode parameter from the request, and then I'm calling a web service with that parameter and writing the response. So this is like the first diagram I showed, where the request object from the connection pool stays alive for the duration of the request. Let's contrast this with the async servlet. Notice that I'm using the web servlet annotation with the async supported true annotation. In this case, I'm going to create an async context and start a new async, passing the request and response objects. And then I'm going to use an executor service, which is a Java SE6 feature, and create a new thread pool of size 10. I'm then going to use that thread pool to execute my asynchronous service. And my asynchronous service is similar to what I had in the synchronous servlet, or traditional servlet. It just parses the parameter and then calls the external web service. So I've written a performance test using JMeter to test these two scenarios. I highly recommend that you do this with your own applications because the results can be quite unpredictable. I'm going to send 100 requests with a ramp-up period of 20 seconds. I'm using a HTTP request which sends it to the sync servlet and passes a parameter. So if I run this test, you'll see that there's 10% errors. And if we have a look at the server log, we can see that the error is 403 forbidden. So we've actually overwhelmed the server with requests. So let's try with the async servlet. So in this case, I've got the same number of threads and ramping up over the same period, so equivalent load. But I'm going to send to the async servlet this time. And if I run this request, you'll see that the throughput is actually improved a little, but in this case, I didn't get any errors. I believe it's because I didn't overwhelm the web service. So as you can see, the async servlet provides better support for calling web services and freeing up the thread to handle requests. The second test was no slower than the first, but the first had more errors. And that's about asynchronous servlet. Using the SSL connector to encrypt communication between the client and JBoss. In some circumstances, you won't need to do this because you'll be proxying requests from the client via Apache to JBoss. In that case, the typical situation is you encrypt communication between client and Apache, and then the communication between Apache and JBoss is within your internal network, and you don't have to worry about people eavesdropping on the communication there. So in that case, you might just use the AJP protocol, which is a binary protocol which cannot be read easily anyway. So I'm going to show you the scenario where you've got a client connecting directly to JBoss and you want to encrypt the communication. So let's start by having a look at this page in the JBoss web documentation. It shows you a quick start on how to use SSL. So the first thing we're going to do is we're going to use the Java key tool to generate a key store and client and certificate. So here's the command we need to use. We're going to create a key store. So we need to enter a key store password, and for the first and last name, make this equivalent to your host name, which is important when you need to get your certificate signed by a CA authority. Fill in the rest of the fields, and then make sure you use the same key store password as you use for the certificate. So then we need to open the server.xml, copy the connector, and change it to be a HTTPS connector. Also, we need to nest an SSL element underneath the HTTPS connector and make the HTTPS connector secure. You can read about this on this page of the documentation. It's got the 3 attributes you can add to the HTTP connector. And then it's got that you need to add the SSL element underneath this HTTPS connector and various attributes you can add. So I'm going to add the minimum attributes required to use a self-signed certificate. So for my certificate key file, I'm going to use the key store I just created in the previous step. So I need to copy the directory where I created it and then paste that into the key store path with the actual name of the key store. Next, I need to add my key store password, which is just password. I need to add the key alias, which is Tomcat by default, but if you specified a key alias when you created your key store, then that's the alias your key is created under. It's also recommended to disable the native connector when using SSL. In order to do that, set the native attribute to false on the JBoss web subsystem. That information can be found in this JBoss community article. You can verify which connector you're using in the server log when the server starts up. If you're using the native connectors, then this line will print. If you're using the non-native connectors, then this line will print. So I can save that now and try testing by running JBoss and sending a HTTPS request through my web browser. So I'm starting up JBoss now, and if I watch the output till it started, I can see that a secure connection was created on the 8443 port, which is the default port for HTTPS communications on JBoss. And if I send a HTTP request to that address, then I can see that I've been asked to verify the identity of localhost. Now, if you use a CA authority to sign your certificate and you had a host name which matched the name in the certificate, you wouldn't get such warnings in your browser. So that's how to add a HTTPS connector in JBoss. Using the Java authentication and authorization service in JBoss 7. I'm going to show you how to use JAS in JBoss. I want to show you by going through one of the examples in the JBoss Quick Starts, which you can find in this GitHub repository. The example I want to use is the servlet security example. It shows you how to secure access to your servlets. There's also another example on security, which is the EJB security example. It shows you how to secure access to EJBs. So in this example application, there's a README file which explains the steps that were taken to create the example. I'm going to go through those steps one by one. So this example demonstrates using Java EE declarative security to control access to servlets. When you deploy this example, you will create a quick start user in a database and then use basic authentication to authenticate that user to access our servlet. So this is the import XML file which creates the user in the database. So you also have to define a security domain in the standalone XML file, which I'll show you in a minute. In order to access the application, you'll need to use the quick start user, which has the role quick starts. There's also another user called guest, which we won't use in this example. So JBoss Web is the deployment descriptor specific to JBoss, and it has a security domain element which defines which JAS security domain will be used to authenticate this application. In the web XML, we've declared the auth method as basic, which means that we'll get the browser pop-up window when we try to authenticate. You could also create a login form which does the same functionality. So the actual servlet is annotated with a servlet security annotation, and it defines the roles that are allowed to access this servlet. These are the same roles that the quick start user has. We now have to define the security domain in our configuration. There's two ways to do this. You can do it via the JBoss CLI, or you could edit the standalone XML file directly, which is the method I'll show you here. Remember, if you're going to edit the standalone XML file, be sure to shut down the server first, so that any changes made by the other methods don't override the changes to your standalone XML file. So look for the security subsystem, and here's the configuration for the security domain we'll use for our application. You notice that it uses the same security domain that's defined in our JBoss Web XML. And also, we can see the query that's used to obtain the principal from the database and the roles for that principal. So if we start up our server now, we can see that our server is ready, and we'll use Maven to package our application and deploy it to the server. Once it's deployed, we can see the servlet context here, which we can use to access the application. And when we access it, we're prompted for the username and password. So that's how to add Java authentication and authorization service to secure access to your application. Securing passwords with JBoss 7. I'm going to show you how to use the vault to secure passwords from the configuration file. So let's start by having a look at this part of the documentation. If we follow the steps in here, you'll see that the first thing it says to do is create a Java key store. This time we're going to use it to store our values for our vault. So let's create a vault key store and give it an alias of vault. Now let's create the certificate with the credentials. It doesn't really matter what you put in here. Then make sure you enter the same key password as you entered for the key store password. You can see that there was a vault key store file created in the same directory as a server key store. The next thing to do is to use the vault script to store a password in the vault. So let's run the vault script, which is in the bin directory. And if we start a new interactive session, the first thing we're prompted for is a directory to store our vault. So let's use this directory and create another subdirectory underneath it called vault. And we're going to pass that to the script to say that we want to use that directory to store our vault files. The next thing to do is to pass the URL to the key store. And this is the one we created in the previous step. We have to create a salt and an iteration count. This is so our encryption is unique. You can see that the mask password is created. then we need to actually add our value. So we're going to add the key store password for the SSL connector here. So we just type in the value, which was password. And then we add a block to store the attribute under and a name for the attribute. Now we have to add the vault configuration to the standalone XML file. So we have to update these values from the documentation to be the URL of the key store that we provided in the earlier step, as well as replace the other values such as the masked password, the key store alias, which was vault, the salt, the iteration count, and the encoded file directory. Now we can replace the password that we had in plain text for the HTTPS connector with the encrypted string, which we got when we added the attribute to the keys to the vault. So let's copy that, and we're going to use the EL syntax, which is a $ and curly braces, and then paste our encrypted value with the block and the attribute name into the standalone XML file. So now let's start up the server again and send a HTTPS request to our server and check if our HTTPS connector is still working. So that's how to secure passwords with JBoss 7 using the vault. Installing the JBoss Tools plugin. I'm going to show you how to install the JBoss Tools plugin into Eclipse Indigo. You can see my version of Eclipse here, Indigo Service Release 2. So if I go to Help and Eclipse Marketplace and type in JBoss Tools in the search bar, I can see JBoss Tools Indigo plugin, and if I click install, I'll have everything I need for the following videos. That's how to install JBoss Tools plugin in Eclipse. I'm going to show you how to build an application and deploy it to JBoss using Maven. I want to show you using the JBoss AS Quick Start. You can download this from GitHub as a zip file using this link, or check it out from Git using this URL. So I've downloaded the zip file and extracted it here on the file system. If I move into the kitchen sink directory, you can see there's a pom.xml file, which is the Maven metadata for the project. I can import that project into Eclipse using the pom. Once I've imported it, I'll be able to edit the files in Eclipse, which makes it much easier to work with than directly on the file system. So if I open the pom, I can see that it includes a bill of materials. A BOM is a collection of versions or a stack of artifacts. We'll use it in this case so that we know that we always have the dependencies that will be available at runtime in JBoss. In this case, we're using the JBoss Java EE 6.0 with tools BOM. So for each of the dependencies that we use from JBoss, we make them provided scope, so they're not packaged with our application. And we don't have to include a version because the bill of materials specifies or defines which version is imported. If we have a look at the README for this project, we see that it includes lots of features from Java EE. It also uses the JBoss Maven plugin to deploy the application directly to a running server. So we have to first start up a JBoss instance. Let's have a look at my Maven settings. In here, I've added the JBoss public repository using this URL. I've also included the plugin repositories, which is a separate repository including the plugins for JBoss. And this is an active profile by default. So now Maven will know where to download all my dependencies from. And if I run the package target, Maven will read my pom XML file and download all the dependencies required to build my project and build it for me as well. After it's finished building, if I look in the target directory, I can see that a WAR file was created. I can also use the JBoss AS Maven plugin to deploy the application directly to JBoss. So that's how to use Maven to build and install an application. Here's the configuration for the JBoss AS Maven plugin, which allows me to directly deploy the application from Maven. So that's how to use Maven to build and deploy an application to JBoss. Using the JBoss Tools plugin to deploy an application directly from Eclipse. In order to add a server in Eclipse, I need to open the preferences, go to the servers section, and create a new runtime environment. If I have the JBoss Tools plugin installed, I should see a list of JBoss community servers here. If I select the 7.1 runtime and point it to a directory where my 7.11 instance is installed, I'll be able to deploy directly to that instance from JBoss. I can also select the configuration file I want to use here as well. In this case, I'll use standalone.xml. So now that I have that runtime, in the servers window, I can create a new server and use the previously configured runtime. Now I'll be able to right click on my project and click Run As and Run on Server. It'll ask me which server I want to use, so I'll use the one that I just created in the Servers tab. Now, if the first time I do this, JBoss will be started up for me, and the console tab will show the standard output from JBoss. All this is conveniently available from within my IDE, Eclipse. And you can see that in the browser view of Eclipse that my application was deployed successfully. So that's how to use the JBoss Tools plugin in Eclipse to deploy an application. Using Aquilion to run a JUnit test suite. I'm going to show you how to use Aquilion to run tests within a JBoss container. So there are a couple of different methods for running Aquilion. You can run it in manage mode, where JBoss will be started and then stopped as part of the test process. Or you can run it in remote mode, where JBoss will be already running and your tests are deployed to the remote server and tested before being undeployed. There's also a third option, which is using OpenShift, which I won't cover in this video. So as well as what's already in the Maven configuration file for the kitchen sink quick start, there's also an Aquilion configuration file. You can use this configuration file to specify a path to JBoss. Or the more convenient method probably is to set a JBoss home environment variable, which Aquilion will use to find where JBoss is installed. So you can see that I'm using the JBoss home environment variable here. And I run the Maven test target using the manage profile which I just showed you. Running your tests in this manner will allow you to be more productive because you can quickly test code as you write it. Because JBoss is so quick to start and only deploys the services that are required for the application that you're deploying, you'll be able to quickly test your code before moving on to writing some new code or refactoring the code that you've just written. So let's review the log to see what actually happened when we run the test in manage mode. So you can see that the JBoss server was started and then we deployed a test war. Some tests were run, and after that our test war was undeployed and the server was shut down again. So that's how to use Aquilion to run a test suite in JBoss. How to write a test case to run in Aquilion. I'm going to use the kitchen sink quick start to demonstrate how to use Aquilion to test your application code. So you can see this uses the JUnit run with annotation, and I pass the Aquilion class to JUnit in order to run this application. You can see that Aquilion also has a deployment annotation which allows me to use shrink wrap to package up a small part of my application for testing. So in this case, I'm going to create a web archive called test.war and add a few classes which I need to test, such as member registration, and the resources class. I'm also going to add a few resources which are trigger conditions for JBoss and a test data source. So I'm going to make this a CDI application by adding the beans XML and also include my data source descriptor. So because this is a CDI application, I can use @inject to inject my class under test. Let's have a look at the class under test. It's a stateless EJB, or a stateless session bean, and it injects an entity manager. Entity manager is created by our container because we have a persistence.xml file, and we use the entity manager to persist an object to the database. You can see the dependencies that are required to run Aquilion. So that's how to test code using Aquilion. I'm going to show you how to set the server logging verbosity. This section of the JBoss documentation explains how to toggle the root logger level at runtime without bouncing the server. I'm going to demonstrate how to do this in standalone mode and domain mode, as well as how to do it using the standalone XML configuration file. You might want to do this if you have a problem with your server and you don't know what's going on and you want to get more information. So first of all, I'll show you how to set it using the standalone XML configuration file. Find the section that says root logger and change it from its default setting of info to debug. Remember, whenever you change the standalone XML file, you should have the server shut down. After you've made your configuration changes, start up the server. So if I tail the server log now, you can see that instead of only getting info level messages, we're also getting debug level messages. This is the desired behavior. Notice how the console only shows info level logging, but when we're tailing the log file, we see debug level logging. You can set the console and file appender into separate from each other. So if we look again at the standalone XML file, here's the console appender, and here's the file appender. This one's going to server log, and this one's just going to standard out. This one's still logging at info level because it's got a level defined for the whole handler. So let's remove this and see if we also get debug logging on the console. We'll have to restart the server to pick up those changes. Now you can see that the console is also logging at debug level. Next, I want to show you how to do it using the JBoss CLI. The JBoss CLI is a convenient feature because it allows you to set the logging at runtime, or as well as change other configuration. So the path to find how to set the logger is this one: subsystem logging root logger root. And if you do a read resource, you can see the current level. Now, after you've done read resource, if you use the change log level command with level set to the new level you want, in this case, I'll change it back to info. You can set the logging level at runtime. And if I do another read resource, I can see it's back to debug. So now if we deploy an application, we can see that the logging level decreased from debug to info. I'll just enable the application now and switch back to the tail of the server log. And there you can see I didn't get any debug level messages about deploying the application. So the last thing I want to show you is how to do it in domain mode. Now, if you recall from previous sections, domain mode is basically made up of a few server profiles, and you assign server groups to one of the profiles and add servers to those server groups. So what I've done here is I'm tailing the server1 log, which is using the full profile. Then if I want to update the configuration, I'm going to use the CLI. And before I go into the logging subsystem, I have to select the full profile. So let me just start up the JBoss CLI now. See, I go profile full, and then I can go into my subsystem and change the logging level as I did with the standalone configuration. I'll set the logger level to debug this time, since it would have been an info by default. And I can check that if I go back to the console and remove my application or redeploy my application. I have the application deployed, and I have it already in the server group. So if I remove that application, then I go and have a look at my logs, and I can see there was some debug level logging. So that's how to add or change the verbosity of the logging in JBoss AS7. Changing the logging verbosity for a single part of the system. I'm going to show you how to add a logging category to the kitchen sink quick start application. So in this application, I've got two logging statements, one at find level and one at info level. In my standalone XML configuration file, I can add a category like so. See here where I've got the org JBoss AS quick starts kitchen sink category. This is under the logging subsystem. I've got it set to level info, but I'm going to change that to be at level debug to start with, or level find to start with. So now when I start up my server, it'll pick up my changes to my logging configuration file. You can also set it using the JBoss CLI, which I'm going to show you next. So once my server is started, I can use my application to trigger this part of the application code. This was in the member registration class, so I'm going to actually register a new member using the name, test, and an example email address as well as a phone number. After I click the register button, that part of the code will be executed and the logging framework will check what logging level to log its statements at. I can see that my new user was registered, and if I check my server log, I can see that both the info and the find levels were logged. If I use the JBoss CLI to set the logging level for that category to info, then I'll see that my find level logging is no longer logged. This is a good way to change the logging at runtime. Notice in the previous screencast that I use the change logging level command, and in this case, I'm just using the plain write attribute. Both work just as well for changing the logging level. The change log level command, I know it exists on the root level logger, but I'm not sure it exists for each category. So for a category, use write attribute. So if I register a user again, I can see that my user was created, and if I check my server log, which I'm tailing, I can see that this time only the info level log was printed. So that's how to set the logging level for a category in JBoss. How to use the async handler to improve the performance of logging in JBoss. The async handler shouldn't be used in all situations. If you're only doing a little bit of logging, there's going to be a bit of a delay before lines get printed, which is not going to be ideal in all situations. However, if you're doing a lot of logging, then you might want to consider the async handler. You can read the documentation on this community article about the async handler and its options. I've added an async handler in the standalone XML file, as you can see here. Note that the subhandler references the file handler, which normally prints out to server logs. So all we're saying is for the file handler, we want that to be handled asynchronously. So I want to run a load test. I'd previously showed you a load test for a web services application. In this web service, I added a call here, which is at find level. And if I send a request to this web service, I'll see that the find level logging is printed to the server log. All that tells me is that the logging is working correctly. So now if I load up JMeter, which is my load testing tool, and send 100 requests quickly at the JBoss instance, I can measure the performance of the application server. In this case, the application does lots of logging. Most of it actually comes from the CXF framework, as well as the logging lines I've added in my application. So in this case, the average response time was 713 milliseconds. If I remove the async handler now, which means file handler will just do synchronous logging, and I retest, well, because I made the changes to the standalone XML file, I have to restart the server to pick up those changes. Let's just wait a minute while the application server restarts. So now if I send another request to the server to check my logging's working correctly again. And in my log, I can see my find level logging here. Call postcode service with 4000. So let's run my load test again. I'm going to send another 100 samples in, and you can see straight away that the average starts increasing. And the only variable that we've changed is the async handler. So that's how to use the async handler in JBoss. Rolling the JBoss logs by size. By default, the JBoss log is rolled at the end of the day. In this documentation, you can read about the size rotating file handler, which rotates the log by size. There are various options, including the size at which to rotate the log file, and a backup index of how many files to keep on disk. If we look back at the default handler, the periodic rolling file handler, we can see that the suffix is where you can set the time at which the log file will rotate. By default, it rotates once a day. So in the standalone XML file, I've replaced the default file handler with the size rotating file handler and added a rotate size of 20 kilobytes and a backup index of 2. I backed up the previous periodic server log file to see the size that it would log with the same test case. We can see that it's about 100,000 bytes. So if I start up the server now and then run a load test to generate some logging, the same test that I'd run previously, I should see that I get 2 backup index files only, even though there's 100K worth of logging. So you can see that the server log file is generated as it is with the periodic log handler. And when I run the test, this log file slowly starts to build before being rotated to some backups. And as we keep logging, the third and fourth time that it should be indexed, those extra log files are deleted. So that's how to add a log file that rotates by size in JBoss. Using logging configuration in your application in JBoss. Usually with your logging configuration in your application, it'll be ignored by JBoss and it'll use its own configuration. This is useful because your logging configuration is centralized by JBoss. However, you can override this behavior, which is what I'm going to show you in this presentation. In this presentation, I'm using the Log4j framework, which is a popular logging framework, but it's similar for other logging frameworks as well. So I've created an application which has a Log4j configuration file and uses Log4j to print to the log. You can see by default it prints to this file. So if I deploy this to JBoss and then send a request to this application, you can see that by default the logging configuration from the application is ignored and JBoss's logging configuration is used. If I look at the server log, standalone log server.log, I can see that my error message log is printed here. So this is okay for some applications, and you could use the logging configuration from the server to change the logging level for this category, and that would be okay. But if you want to override the behavior and have a logging configuration, this is how you would do it. So add an exclusion to the Log4j framework so that it's not loaded by the application server, but loaded from your application. Note that I'm also shipping Log4j with this application. So now when I send a request to the server, you see that nothing is printed to my server log file, but if I check the log file for the application, which was in the temp directory, then you'll see that the log message is actually printed there. So that's how to have a logging configuration in your application in JBoss.